Tell me basically what we got going on here. What are real shocks?
Well, the name Real Shocks actually belongs to the website, but the concept is kind of wrapped around we're taking the Real Shock technology and bringing it into RC. So we were trying to come up with a catchphrase or a name that was really going to identify the overall project. The project's going to start with the bypass technology, valve technology. We're going to move into seal packs, which is all the sealing system, O-rings that are in the shocks, and all the whole stacking assembly, how that works, and shock shafts. We have some shock shaft technology that we're going to introduce also. And the project will most likely conclude with the actual real shock, but that's probably going to be, probably 3 years down the road.
Oh, so it'll be a complete shock.
That'll be the actual shock that MIP is going to offer as a separate product. But when we get to that point, it's after we've introduced and let the valve technology kind of seed into the industry. Because right now it's so new, and as anything is new, it takes a while for it to really grasp. But we can see that the advantage of this technology is just a matter of time.
Right.
But somebody has to get it going, and we're going to champion that.
So kind of give an explanation of what this valve technology actually does for the shock. Like, what does it actually do?
Well, primarily it allows you to separate either rebound or compression resistance with also having the ability to have bypass. And what bypass means is when the shock is hit abruptly, the valves will collapse completely and allow the shock to actually move. The opposite of that is pack. When you have an abrupt hit, usually the orifices where the fluid's flowing through will restrict because it can only flow through so fast, and that will cause the piston to actually theoretically stop. It doesn't physically stop. It may come to a stop when all the points of velocity kind of reach their completion, the spring compressing, all the movement of all the components, and then of course the resistance. But it's kind of just offering that technology or ability, to be used in a shock of this size. So we've actually done valves in metallic materials as well as in the polymers until we actually found something that would work. And the way we made sure that it worked was we created our own dyno and our own pack tester to actually prove the technology.
Why would somebody want different compression and rebound rates?
Well, there's several reasons, but basically it's so that you can either create the right amount of compression resistance for the drivability of the car or the right amount of rebound resistance for traction. So right now you're not able to separate those two out. And there are some systems that allow you to have a difference between compression and rebound, but you don't have a level of adjustability or of tunability. And you also don't have a company that's backing that with the technology, the testing, and all the science to go along with it. The overall design of the system has a couple of key components. The piston design is very key because unlike any other piston that's used currently in the RC industry, the oil actually has to flow around the periphery for resistance with the oil that's used. And then of course through the orifices and across the valves for the resistance that you need in that direction. So the piston is very unique. It's something that has not been done. If you take all of the valves out of the system and try to use the piston by itself, there's no resistance. So the valves have to do work to shut off in one direction for the oil to flow around the periphery, and then they also have to do their work for the resistance in the other direction, which is actually when they flex. The other major component are in fact the actual valves themselves, because the materials that we found to use is very unique for this application, and it comes in multiple colors, so it's easy to identify thickness. We thought that was extremely key, and it's actually part of our patent that we're working on, because now you're able to have multiple valves and not have to have precision tools to measure them. You can actually look at them and go by color to determine what thickness they are, and therefore what resistance you're going to end up using. Okay. The last component is what's called the stop washer. That's what the valve actually is rests underneath the valve, and that determines the flex characteristic of the valve. So when the oil flows through the large orifices and deflects the valve, the washer that's underneath it has a specific diameter or a specific shape that allows that resistance. So when we're setting up the initial design for a Bypass1 system for a shock, we're actually tuning it for resistance based on not only the octagon shape on the outside of the piston, but we're also using that stop washer for the resistance characteristics of the valving. That way we're able to use minimal valving to get what we want. Eventually, over time, those stop washers will be available in multiple sizes, which will also allow you another tuning aid also for those that want to take it to that next step. So the ability of this system is infinite. There are no limitations as far as what you can get. The only thing it's missing at this point from a technical standpoint is the ability to have resistance at different levels in the shock. But trust me, that's coming.
Is that the hint of Bypass1, meaning there's a Bypass2 coming?
Bypass1 is Bypass1 for a very specific reason.
This is the shock dyno. I don't think many people probably think about their shocks and how maybe even any of them became designed. Is this unique to MIP, or is this something that is a standard? Would you walk into anybody's other shop and see something like this?
No. Shock dynos, when we originally started looking at them over a year ago, we went to the full-scale shock dynos companies, and they would be willing to, or they were able to, maybe devise something specifically for us, but we're talking requirements that are probably a 20th of what they're actually able to put out. So after looking at the overall concept and design, and after working with a couple of dyno companies, we decided to just go ahead and build our own. Also, they did not have the ability to understand our pack technology, or how we use pack in this industry. Because in full-scale racing, you cannot have pack. It is like, it's a bad thing. It'll kill you, literally, because you don't want the system to lock up or freeze up when it's compressing. You want constant absorption to the point where you get to the bump stops, which we don't have in this industry. There's a lot of things that exist in the full-scale world that don't exist here, but this is the one commonality, the dyno. And the dyno allows us to check both compression and rebound resistance at a specific velocity. So what we've done is we've decided on a base oil viscosity, and then we have our base RPMs, which will give us a certain either inches per minute, foot per minute, whatever way you want to calculate it out, so that you're actually checking what that velocity is. But we're able to do it consistently. We initially learned that the seal pack has a lot to do with the initial movement of the shock and just how much that resistance can affect traction, as well as just affect the overall performance of the shock. We actually did a comparison of different manufacturers' shocks and compared the amount of resistance just in the seal packs, and found that some of them were great and some of them were awful. And the seals are important, because you do have at some point, in order to create traction, you do have some static resistance that can either interfere because of that very, very slow movement when the tire is trying to follow the ground.
Okay, so now let's talk about pack, because I guess maybe I never even thought about it as why we're kind of maybe the only shock industry that has that. When you talked about reducing it, you always talked about it as that you wanted it. So how does that change something in the actual shock, and how does that change the performance of the car not having it?
Well, currently most drivers will set up their cars so that if they either drop it or, mainly drop. Some people will lift the front and drop it, or lift the rear. Some people will do the entire car. But they'll basically do the drop test. And what they're looking for is whether or not the car bottoms out. So we're actually looking for a certain amount of resistance that's created from the oil flowing through the orifices to actually stop the car as it's in its downward motion. The problem is when you get the pack that you want, which means you can drop the car from a foot and it doesn't bottom out, or it immediately comes to ride height, that means you also have a similar type of resistance for rebound. Well, if you have that type of resistance for rebound, it's going to hinder traction. So you're actually fighting one thing or other. So what you're finding now is a lot of the really good drivers are running a lot less pack than they want in order to get the right amount of traction. So they're running, because they have to run less rebound, they have to run a softer spring with a softer tire, and that's what gets them around the track fast. So now, with this technology, they'll be able to go back to the pack that they want, but also have the rebound that they desire for traction.
So now, are you designing this around one oil?
Yeah, the initial design that we started with did use one oil, and it had multiple valving for compression and rebound. This particular patent pending technology that we're offering now allows you to use the oil on the valve side. So whatever side the valve is on, the oil has to flow around the valve, around the periphery of the piston. So that's going to create whatever resistance is allowed by whatever oil you're using. The valves for the other direction, when the oil now has to go through the orifices, which our orifices are not designed to create resistance, but instead bypass, now it has to go through the valves in order to determine how much resistance or dampening you have. So the more valves you put on or you use, the more energy that is necessary to deflect those, and therefore the more resistance or dampening. And at some point, if that resistance or velocity gets too high, the valve will collapse and allow it to just move freely, or allow it to move with minimal resistance up, and that's your bypass. Bypass in itself mainly comes in handy for really, really rough tracks. On the racetrack, I think the guys are primarily going to end up with the reverse setup running, where they have, where they're controlling the amount of pack based on the oil viscosity, and they're allowing, and then controlling the rebound with the valving.
What kits is this available for? What is it going to be for every kit, or is it going to be?
Initially, we're introducing it for 10 scale buggy, 10 scale truck, both stadium truck and short course truck, 2-wheel and 4-wheel, associated, Losi, Traxxas, and as we go down the road, we're going to be looking at Kyosho, Tamiya, HPI. I think HPI is on the list right now. Durango. I mean, our list is huge because essentially this concept can stretch into every RC possibility, as well as motorcycles, anything with a shock. As a matter of fact, our patent says it's anything with a shock. That's RC. So it doesn't necessarily have to be a car. We'll get into on-road research probably later this year and see where their needs are. We have some ideas right now what we'd like to do, but at this point our focus is off-road because that's the base of the company right now.